Now finally a question from coordinate geometry. It is given there are two circles, C1 having center at origin and C2 is another circle having center at 3, 4, radius 4, and C3 is another circle having center at h, k and radius is r. Now C3 it is given that it is satisfying following condition. The center of C3 is in collinear with the center of C1 and C2. C1 and C2 both lie inside C3 and C3 touches C1 at M and C2 at N. Now we have to answer the following question related to this. So let us see the figure first here. What is the figure here for us? So this is the figure for us, which is actually showing you the complex condition which is given in the problem. Now this is C1, this is C2 and this is the C3, which is touching both the circles, and it is given that the center of these three circles are collinear. So first we are going to apply the condition of collinearity. The center of the first circle is 0, 0. The center of the second circle is 3 and 4, and the third circle is h and k. So this is equal to 0. So this will give you first condition 3k is equal to 4h. Now let us move ahead. You can see here if the centers are collinear, so definitely this is going to become the diameter. Let us say this is Mn and this is going to become a diameter. So you can clearly see from here the radius of the first circle which is given to us. The first circle is having radius 3 and second is having 4. So let us check it out from here. This is 3. It is given that this is 3 and the radius of this is 4, and we know this is the diameter. So definitely now we have to calculate the radius of C3. Now here you can notice that a very important condition, that this is going to become a diameter of the bigger circle. Now what we can have from here, that this is having radius 4. This is given that this is having radius 4 and this is having radius 3. So this is 3 and this is 4, and also you can check that this center is 3, 4. So this will be equal to 5. So in total 4 plus 3 plus 5, which is equal to 12. This is the diameter of the circle C3. So this is equal to twice of r. So r, that is the radius of C3, we will get from here, that is equal to 6. So this is the fact we have derived from the figure. Now let us get another equation in h and k. As it is given that C3 touches C1 at M, so the distance between the centers of C1 and C3, that is D, which is equal to under root h square plus k square, is equal to difference of radii. So from here r is equal to 6. So h square plus k square is equal to 9 here. Now this is the second equation in h and k. The first one was this. So from here we can calculate the value of h and k. So h from here will be equal to plus minus 9 by 5 and k will be equal to plus minus 12 by 5. Now it is also given that the circle C3 is there. So if you calculate the values here, you will see 2h plus k is equal to 6. So for the first, the correct option is P, that is equal to 6. Now let us move on to the second one. We have to calculate the value of the length of ZW and the length of X and Y. So what was X and Y and ZW? Let us see here. So next we have to calculate the length of ZW and X and Y. X and Y, it is given that these are the point of intersection of first two circles. So this is X and this is Y. Now this can be easily done. How? Because we know this is the common chord and we can easily calculate the length of common chord. This one we can easily calculate. Also this is also the chord and we know the center and we know the radius. So we can find out the chord of these and this can be easily done. So this line is known to us. Merely by subtracting the first two equation we will get the equation of xw. So if you calculate the length of these two, the correct answer will be equal to root 6. Now finally the ratio of MZN and ZMW. MZN. So this is MZN and MZW. These are the true triangles and we can again with the same data, with the same fact, we can calculate the area. This can be done very easily. Now these are perpendiculars. So the area can be find out very easily. So MZN, for MZN we can have half base into perpendicular. So this is the perpendicular. Again for this half base into perpendicular, this can be easily done again. So if you want to calculate MZN, look here, MZNN. So area is half MN into ZP. Let's say this point is P. So it is PZ, and again the area of this triangle is half ZW into MP. Now you can notice these two can be eliminated because PZ is half of ZW and MN definitely we know it and MP also can be find out very easily. So if you calculate this value, this will come out to be, the value will be 5 by 4. So the answer for the third option is 5 by 4. Now let us calculate the last thing, that is alpha or A we can say. So what is given, that it is again given that the line through X and Y intersect C3 at Z and W, and let the common tangent of C1 and C3 be the tangent to x square is equal to 8ay. So this is a parabola and this A, or we can say alpha, this is actually A, we have to calculate the value of A. So there is a condition of common tangency we have to apply. So let us see how this can be done further. The tangent, the common tangent to C1 and C3, it is clear it can be drawn at M. So it will be parallel to this line X and Y. And what is the equation of X and Y? It can be easily written. So if you calculate the equation of X and Y, which is the common chord, it is basically 3x plus 4y is equal to 9. So the slope here is equal to minus 3 by 4. With this slope, we can find the equation of tangent to the circle x square plus y square is equal to 9, and that tangent we can easily get to this circle. So let us find out that tangent. So tangent will come out to be, with this slope, y is equal to mx plus minus, we have a under root 1 plus m square. This is 9 by 16. So if you calculate it properly, it will be 4y plus 3x. Now the tangent is with the negative slope, and if you calculate this value will come out to be minus 15. Now we have taken only one value, that is minus 15, because the y-intercept is negative. So this is the tangent. Now applying the tangent, the condition of tangency to the parabola, because it is also a tangent to the parabola. So this line is a tangent to the parabola, that is x square is equal to, the parabola is given to us, it is 8ay. If you apply the condition to this, you can put y here and make the discriminant 0. You will get the value of a as 10/3. So the correct option for the last one is option U. So this is the correct option. Let us move on to the next problem.